Welcome to the last lesson in Module 1. Today, we're diving into conditional statements in logic. You probably know them as if-then statements. They're what drive logical reasoning. Let's start with a simple idea, a promise. Imagine I make you this promise. If it rains tomorrow, I will give you $10. Think about this. Under what circumstances, and only those circumstances, could you rightly call me a liar? So far, we've learned about our basic logical connectors. We've seen and, or, and not. These are great for connecting static facts about the world. But the real power of logic comes from exploring consequences. This is where the conditional statement shines. Let's break down the anatomy of a conditional. We write it in plain English as if P, then Q. And in logic, we use this symbol, P arrow Q. The P part is called the hypothesis. This is the condition, the if part. The Q part is the conclusion. This is the result, or the then part. Let's make this concrete. Instead of rain, let's use a different promise. Let's say P is the statement, you get an A on the exam. If you do that, then I promise Q, you get 100 in the course. If P, then Q. This is our promise. Now let's test it. There are 4 possible scenarios. Scenario 1 is P is true and Q is true. This means you get an A and you get 100 in the course. Is the promise broken? No. I did what I said I would. The promise is kept. So a true hypothesis leading to a true conclusion means the conditional statement is true. Scenario 2 is P is true, but Q is false. This means you get an A, but I don't give you 100. You get an 85. Is the promise broken? Yes, this is the exact scenario where you can call me a liar. I broke the promise. A true hypothesis leading to a false conclusion makes the conditional statement false. Scenario 3 is P is false, but Q is true. This means you get a B, not an A, but I give you 100 anyway, maybe because your other work was so good. Is the promise broken? No, the promise was not broken. My promise only triggered if you got an A. You didn't. So my promise is not violated. So a false hypothesis leading to a true conclusion is still true. The promise wasn't violated. Finally, scenario 4. P is false and Q is false. You get a B and you get an 85 in the course. Is the promise broken? Again, no, the promise was not broken. My promise only triggered if you got an A. Since you didn't, my promise is not violated. A false hypothesis leading to a false conclusion is also true. This leads us to the complete, formal truth table for the conditional. We have our P column, our Q column, and the result of P arrow Q. If P is true and Q is true, the result is true, promise kept. If P is true and Q is false, the result is false, promise broken. If P is false and Q is true, the result is true, promise not violated. And if P is false and Q is false, it's also true, promise not violated. Notice this. This is the most important takeaway. A conditional statement is only false when a true hypothesis leads to a false conclusion. In all other cases, it's innocent until proven guilty. We assume the promise is true unless it is actively broken. This isn't just an abstract game. This structure is the basis for all scientific and legal thought. In science, we say, if general relativity is true, then light should bend around massive objects. This is a testable prediction. We observed this in 1919. The hypothesis led to the predicted conclusion, supporting the theory. In law, a contract is a conditional. if you pay your rent. Then you are entitled to occupy the apartment. The court's job is to step in only when that promise is broken. When P is true, you paid, but Q is false, you were evicted. Let's summarize what we've learned. First, P arrow Q is the logical symbol for if P, then Q. Second, it's best to think of it as a promise. It's only broken if the condition is met, P is true, but the result does not follow, Q is false. This means the only time a conditional is false is the true implies false case. Master this, and you've mastered the engine of logic. These statements are the foundation for deduction, reasoning, and building complex systems. In the next module, we'll use this powerful tool to build our first mathematical proofs. See you then.